Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial where I'm showing you how to code your own cryptocurrency and build your own ICO on Ethereum. In this video, we're going to deploy the smart contracts that we've built up to this point in the tutorial to the Rinkeby test network. So the idea is that we have, developed our project locally. We've run our smart contract with Ganache. But today we're going to start using Geth and get our contracts off of our machine and onto a test network. So if you haven't seen the videos up to this point in the tutorial, be sure to check those out. And also subscribe to the channel if you'd like to see, the rest of the videos in this tutorial series. And make sure you turn on notifications with the bell below so that you can be notified about them when they come out. And if they're already out, you can just check the link at the end of this video or watch the next video in the playlist. So up to this point in the tutorial, we have, developed all of our smart contracts locally with Ganache. Ganache has been our, in-memory blockchain that we have used to, develop and deploy and test our smart contracts. But in order to, deploy the smart contracts to a test network or the main network for that matter, we need to move beyond Ganache to something a little more robust. Now, Ganache is great for, developing things quickly and, these tutorials and things like that. And, Ganache has the same interface as, the main network and things like that, but it's got different internals. Like it works, completely differently on the inside. It's an in-memory blockchain, and we want to, connect to a real blockchain, and that's what we're going to do in this tutorial. So I will minimize this. So instead of Ganache, we are going to use something called Geth, which you might already be familiar with. Geth is a Go implementation of Ethereum. I'll show you that. So this is the Geth repository on GitHub. You can kind of read more about this. You can see the link, geth.ethereum.org, and it will tell you about it. So I'll leave you all to that if you want to check that out. But yeah, we're going to be using Geth. So essentially what we're going to do is install Geth on our machine, and we're going to run our own Ethereum node. So, how this is different from Ganache is, Geth is a full-blown Ethereum node, and we are going to, use it to, we're going to run that process to connect to the Rinkeby test network. So when we use this node, we're going to be directly connected to the Rinkeby test network. So let's explain that for a second. Fundamentally, when you're connected to the Ethereum blockchain, as a node, you are participating in the network. So we're going to start a process on our machine that, performs a lot of the similar responsibilities as a web server, but, we're going to be a node, a process that's, helping run the entire network. So we're going to, download Geth and run it so that we can be, a part of that process, a part of running the network. And we'll use Geth and our Ethereum node that we spin up in order to deploy our contract and connect to the test network. So let's go ahead and install Geth. I'll point you to these installation instructions. I'll put a link to this down in the notes below this video. These are the installation instructions for Mac. That's what I'm going to be using. If you'd like to, you see the instructions for a different machine, I'll leave that to you to check that out. But this is how I'm going to do it on Mac. This is with Homebrew, the package manager. You certainly don't have to use Homebrew, but it's the easiest way for me. There's a variety of ways you can go to, the a website for Go Ethereum and download it directly if you wanted to, and copy it to your user local bin. There's all kinds of ways you could do it, but I'm going to use Homebrew. If you don't have Homebrew, you can install it first. So just looking at these instructions, what we would do is first we want to add the tap. So we do that like this. We'll just watch these instructions here. We do brew, tap, Ethereum. All right. So I've already done this, but I'm going to cancel. But you want to, finish that step. And then we would do brew, install, Ethereum. And I've also already done this, but you'll, wait for this entire thing to finish if you haven't done this already. So yeah, if you can complete both of those steps, you have successfully installed Geth. We can kind of check that out by, saying which Geth. And if you get user local bin Geth, Geth has been installed. You can also say Geth version. I'm using 1.7.3. This is a stable version. So I'm going to clear this. So those are two things that you could kind of use to verify that your installation was successful before you try to execute any more steps in this tutorial. If it's not, you want to kind of stop and try to figure out why Geth may not have worked correctly. But if you did, let's continue. I'm going to run Geth first. But before I do that, I'm going to actually kind of split my windows here so that you guys can see what's going on. I'm going to maximize this. And I'm actually going to start a tmux session. So tmux is just a terminal multiplexer that's going to allow me to split my panes here and manage sessions in the terminal. If you're kind of just curious about what that is, you can see this here. This is the Wikipedia page for tmux if you want to kind of read more about this. But this is what I'm going to be using to split my panes and things like that. So I don't want to throw you off, but this is some extra credit if you want to check this out. So yeah, I'm going to start this by going tmux a-t. I've already got a session running. So I'm in our token sale directory for our project, and see this is just giving me two different panes. And I'm going to kind of use these. I'm going to run the Geth node here, and I'm going to run a console here. So let's try to start Geth. We can do that like this, Geth. And I'm going to connect to the Rinkeby network. Now let me explain that. So there are different networks on Ethereum. And, we used our local network when we were using Ganache. But in order to, deploy our website, our token sale website, in order to deploy the smart contracts for this website, we want to use a test network. We don't want to use the main Ethereum network. So you can see if I open MetaMask, we can choose the networks. There are several listed here. Some popular options are, the Robson test network or the Rinkeby test network. So the main Ethereum network, right, is where, it's just like what you think it is. It's the main network that you would connect to if you wanted to spend real Ether. You might have seen my other tutorials where I've used the Robson test network with Remix. That's also fine, but for this tutorial, I want to use the Rinkeby test network. So I should note that any Ether that you use in this tutorial on the Rinkeby test network is not worth anything on the main network. It's fake, and that's actually good because we want to just test things. We want to test how our smart contract works in a testing environment before we put it on the main network. So yeah, the goal is to get this website off our machine and get the smart contracts onto that test network first. So we're going to run our Geth node with the Rinkeby network. We're going to actually connect our node to the Rinkeby network. We can start Geth, connected to the Rinkeby test network like this. I'll explain this here. And I can, potentially even paste this command down in the show notes below. I'll go ahead and do that so I don't forget. Okay, so let's explain these parameters. I'm going to start Geth. I'm going to tell it to use the Rinkeby test network with this flag. I'm going to tell it to use the RPC flag and also specify some libraries that I want to have in the Geth console with this RPC API flag. I want to be able to use this personal ETH network Web3 net. Then I'm going to specify the IPC path, and this is the kind of default path that was set whenever you installed Geth with Homebrew on a Mac. If you're not on a Mac, this is going to be different for you. I'll leave that up to you to figure out what this value should be. So let's go ahead and start Geth. And in this window over here, I'm going to start the Geth console with Geth attach. Okay. Now, let's explain what's happening over here. This is our Geth node, which is going to be a node connected to the Rinkeby test network. And when we connect to the Rinkeby test network, we have to download its data. Now, why is that? Because, when we're a node, we are, participating in some of the similar responsibilities as a web server. All the data on the blockchain is distributed, so if we're going to participate in that, we have to get all the data. Now, if we were going to connect to the main network, the data is quite large, and it's still somewhat large on the Rinkeby test network, but we have to wait for all the data to download, and that could take some time, depending on if this is the first time you've ever done this, or basically how up to date your local instance is. So you can see some activity here. We can track whether or not Geth is syncing still by going to our console and typing ETH Sinking. Okay, you can see the progress by checking the current block and the highest block. All right, so this is what we want to sync up to. This is our upper limit, and this is our current progress. We can watch this number change. See, it's a little higher now. And I can also show you that we can see the blocks on Etherscan. So this is rinkeby.etherscan.io. Make sure you use the Rinkeby subdomain if you want to, specify the Rinkeby test network on Etherscan. So we can see the blocks over here on the left on the home page. We can see, this number here. Last 3 digits are 318. We can see this over here, 315. So that's a little behind, but it's pretty close. So these, blocks should be roughly the same. Now, while this is syncing, let's go ahead and create an account. We need an account to connect to the Rinkeby test network. So I'm going to exit the console. All right. So we can create a new account like this, Geth-Rinkeby. We want to specify the network that we want to create the account on. That's very important. We'll say account new. All right, now your new account is locked with a password. Now, it's important to know that our accounts are either locked or unlocked. So this is asking us to give us a password. So I would suggest that you use a real password for this. Don't just say ABC123. Don't use password. We're going to create something that's public facing on the Rinkeby test network, and it's not real Ether, right? But you still want to, you still want to protect your account. So I'm going to use a real password. Okay. All right, so here's our account address. I'm going to copy this. So now that we've created that account, we want to do the next step, which is get some Ether on this account. So we have a brand new account, and we need some Ether. so that we can actually, deploy our smart contracts, right? We're going to create a transaction. We're going to send a transaction whenever we, deploy our smart contracts. We're going to change the blockchain, and that's going to cost Ether. So we need some Ether in here. Now, a note about the Rinkeby test network is it uses a different consensus algorithm from the main network. You can't actually mine on the Rinkeby test network. And this is because it's just a test network. It's for development purposes. And, it's not really decentralized. It's actually centralized, right? To filter who can mine and who can't. But for our purposes, that's okay. So because you can't mine and you can't, earn your own Ether, you actually have to request Ether on the Rinkeby test network. We can do that with this website. I'll pull this up. We can go to faucet.rinkeby.io. So let me explain, what this is. A faucet is a smart contract that essentially can dispense Ether. And this is how we're going to get Ether and fund this account that we just created in order to, deploy our smart contracts. And this is pretty easy because we can't mine. We have to, request Ether here. I'm going to request some like this with these instructions. Essentially, what you have to do is create a social media post to say that you're requesting some. And then you have to paste the link to that post in here, and you have to specify the amount that you want, and it will send them to your wallet. So let's walk through that. I'm going to use Twitter. You can use either of these three social networks that you like, Google Plus or Facebook. I'm going to use Twitter. So I'm going to create a tweet. And this is just going to say requesting Faucet funds into this account on the Rinkeby Ethereum test network. So we want to take this default account and replace it with the account that we just created in Geth. You can see this. We'll take this here and copy it. So we're going to paste that value here. Make sure you preserve the 0x. So this was, the value that we copied from our terminal. And yeah, make sure you start with 0x here. So we'll send a tweet. So find the social media post that you created. I'm on Twitter. And this is my Twitter account. You can look me up on Twitter at Dapp University. Follow along for daily updates and shoot me a tweet or two. And yeah, so this is the tweet that was created. We're requesting Faucet funds to the Rinkeby network for this address. So copy this status, whatever link you use, might have been Facebook or Google Plus or Twitter. Just copy the post URL, and we'll go back to the website here, and we'll paste in the status address. So we'll say, give me Ether. This is going to have a few options depending on how much Ether we want and how long we want to wait. So there is a cool-off period. So essentially, if you want 3 Ether, you have to wait 8 hours before you can request any more. 7.5 1 day, 18.75, 3 days. So the reason for all this is, you can't mine on the Rinkeby test network, and you have to request Ether from a faucet. And really, this is just to prevent spam attacks. If you had the ability to mine unlimited free Ether, who cares if you just go around and spam people's apps? And that's kind of why this is here. So I'm going to just choose 3 Ether to wait 8 hours. Click this. And all right, so funding requested, accepted. It found our Twitter posts, and it found the account out of there. So we will sit here and wait. We'll see this go through. You can watch the status bar. And when this is finished, we're going to go into our console and check the balance to see if this actually got any Ether. Okay, so it said it was funded. We'll minimize this. So we can see our account is if it's funded or not by going to the Geth Console. And we can say, Geth attach. And let's check our accounts like this, ETH accounts. Here's a list of accounts, that we have. I've got several. You might just have one. So really we want to ensure that the first account in our list is funded. Full disclosure, this is, this is the one I just created on my network and requested Faucet funds here for. If you have one, you really just want to ensure that this one is funded, because that's the account that we're going to use to deploy our smart contracts. So I can get that account by saying eth.accounts 0. All right. So we want to say Web3 eth.get balance. We want to check the balance of this account. Oops, sorry. Sorry, a little typo there. So yeah, you can check the balance of this account by just saying eth get balance, eth.accounts 0, just the first account. And you should see a non-zero value here. And if you do, that means that your account is funded. Now remember, this is the amount of Ether you have expressed in Wei. You're not just like the richest person on the planet. This is how much Wei you have. This is the smallest denomination of Ether. So it's a lot less Ether than this. So yeah, just ensure that you have a non-zero value here before you continue. If that didn't work, you might want to troubleshoot your Faucet funds. But for now, just make sure that the first account on your list has some Ether. So the next thing we want to do is actually add some configuration to our Truffle project so that we can deploy our smart contracts. So now we have an account with some Ether that we can deploy. Now we want to configure our project so that we can deploy it to the Rinkeby test network. So I'm going to exit the Geth Console, and I'm going to open this project in Sublime Text. Okay. So what we do to configure our project to deploy to the Rinkeby test network is add some additional configuration. So find your config file. This will either be, truffle.config.js or truffle.js. So if you're on Windows, you're probably using truffle.config.js or truffle-config.js for the reason I mentioned in one of the first videos, because of the naming conflict with the executable. But if you're on a Mac or otherwise, like me, I'm using truffle.js. So what we want to do is add some configuration to this networks object. We do that like this. We essentially just add a network, and we say Rinkeby. We say host, localhost. Okay. We say port. This is 8545. This is the port that we're running Geth on. We say network ID 4, and gas. We'll say 70. Oh, sorry, 47. Yeah. So let's explain this. We're basically saying host and port is for Geth. This is, the node that we're connecting to. And the network ID is going to specify the network that we want to connect to, in this case, Rinkeby. So there are different numbers here. 1 is the main network, 4 is the Rinkeby test network, and the other test networks have, different numbers. So this tells us that we are going to Rinkeby, and we're just going to name this Rinkeby so that we know what we're doing here. So we'll be able to specify this network name whenever we deploy our contracts. So I'll save this and minimize. All right, so now that we have our Truffle project configured to deploy our contracts to the Rinkeby network, there's one more step that we need to do before we can deploy, and that is we want to unlock, the first account in our list. Okay. So remember, when we were using Ganache in the previous tutorials, we were able to, deploy our smart contracts and Ganache would by default use the first account in a list, and that's kind of a similar thing we want to do here, but we're going to just specify that account, but we'll use the convention of using the first account. Sorry, this is still loading. I think Geth is kind of slowing things down here. Yeah, we'll just close this for now. So we can unlock our account in order to deploy. This is essentially just going to give us permission to use this account for deployment. So we will open our console, and we'll use the personal library that we injected whenever we started Geth to unlock our account. We'll use that like this: personal unlock account, and we'll say ETH accounts 0. We'll say null. We'll say 1200. So let's explain what's going on here. So I'm going to use the personal variable here to unlock the account. I'm going to pass the account in. So null here is going to be the password. If I, when I submit this command, it's going to ask me for a password. I pass null here because I don't want to actually type my password out on the screen. I suggest that you don't do that either. And here is the amount of time we want to unlock our account for. This is expressed in seconds. This is 1200 seconds, which I think is like 20 minutes. So essentially, this is going to say, hey, let's unlock this account for 20 minutes. And I want to specify some sort of time here because I want to know how long my account is locked for. There may be some like default kind of cool off period for this. I don't really know, but for now, I'm just going to say, hey, unlock my account, because otherwise I don't want to have to manually, lock my account. I want to just, keep it unlocked for a certain amount of time. So I'll hit enter. I will, enter my passphrase that I created in the tutorial when we created the account. So now our account is unlocked, and this is the final step before we actually deploy our contract to the blockchain. So if that was successful, you want to also see if your Geth node has finished syncing, and you can check that with ETH Sinking. All right, so mine is not quite done yet. So if yours is not done either, you must wait for this to finish before you deploy it. So I'm going to pause the video and wait and get back. And I suggest you wait and do the same before you proceed with the tutorial. So once Geth is finished syncing, you can check to see ETH.syncing is false. If you don't see an object here, you've successfully synced Geth with the Rinkeby network. Or you synced your node with the network. And yeah, this might have taken some time for you. It took some time for me, depending on how fast your internet connection is, et cetera, and how much you had already downloaded before. So now that we have ensured that Geth is synced, we can deploy our contracts. So I'm going to exit the console. And we want to migrate our contracts, much like we did in the previous tutorials. We can do Truffle, migrate, and we'll use the reset flag like we did before. And we'll say compile all. And we will specify the network. Now, I'm not going to run this yet. I'm going to show you why that works. This is the network right here that we specified in our configuration file, and it's going to know to use network ID 4 to correspond to the Rinkeby network. So we will run this, see what happens. This is probably going to take a second, and that's okay. All right, so I actually got an error here, and I'm going to leave this on the video so that you all can handle this type of thing too, in case you get it. let's see what happened. So it started running our migrations, and it said an error was encountered. It's bailing. So it's saying that there's an authentication error, authentication needed, password or unlock. Okay. So remember when we when we unlocked our account earlier, we specified 20 minutes, and it took longer than 20 minutes for my node to sync up. So we want to unlock that account again. So I'm going to open the Geth Console. All right. And I'm going to say personal unlock account, ETH accounts 0. Oops, sorry. And I'm going to say null for password and say 20 minutes again. So 1200 seconds. Oops, sorry, typo. And I'm going to enter my password. All right. So now it's unlocked, and I'm going to exit. All right. Now let's rerun our migration. So truffle migrate -- reset -- compile all -- network Rinkeby. And let's see if it works this time with an unlocked account. All right, so it's deploying. It's using the network. We have successfully authenticated with that account that's required to deploy our contract. And we'll just wait for these migrations to run. You can see that it's deploying the initial migration. Tell you what, I'm just going to pause the video until this finishes. Okay, so my contracts were migrated successfully. You can see that these transactions were submitted over here in our Geth process, our node process, and we can see the logs here. So we can also open our project and kind of check on the success of this. I'll show you something pretty neat. So Truffle keeps track of the addresses of our contracts that are deployed to different networks in these contract JSON files that are built whenever we run migrations. So let's take a look at our ERC20 token contract. Here's the big JSON file. We'll go to the bottom. We can see that these get diff markings, we can see that some new information was added here. We can see that a new network was created. We can see network ID number 4. This corresponds to the Rinkeby network configuration that we just created. And we can see that we have an address. So this is Truffle's keeping track of the address of this smart contract that's deployed to the Rinkeby test network. We can go to Etherscan to check out the state of this contract address to see if our migration was successful. So we can just enter an address here and type search. All right, we can see a transaction hash, a block number, the age, just 3 minutes ago. This was successful. And we can see the contract creator. This is the address that deployed the contract. And yeah, it's pretty cool. So we can just, we can see all this information here. We can see that it's telling us that this is a smart contract too. We can do the same thing for our token sale contract. Go back to our project and see the Dapp token sale. We'll go to the bottom of our file and copy this address as well. Go back to Etherscan. Yeah, again, make sure you're on the Rinkeby subdomain. Don't try to look for this on the main net. You probably won't find anything. So yeah, here's another contract address, and this is our token sale. All right. So we have successfully migrated our smart contracts to the Rinkeby test network. That's pretty exciting. We're getting really close to being able to use the deployed contracts with our front-end client, with our token sale website. We'll be able to connect to these contracts on that network instead of our local network. We're getting really close. We just got one more thing to do. And this is a step that's going to be particular to our project, not necessarily other projects that you might build. We need to give our token sale contract some tokens. Now remember, when we created the tests for our token sale contract and when we created our front-end client, we had to do this step. So we had to provision 75% of all the tokens to the token sale. And again, if you don't have all this code, you can just look at the GitHub link in the show notes below this video to find this code. So we need to get an instance of this token that's deployed to the Rinkeby test network, and we want to actually call the transfer function and send some tokens to this address. So, and we want to do a certain amount of tokens, and we want to do it from the admin. So what are the steps here? Well, we need the token sale address, which we have here. That's easy to get. Token sale, go to the bottom of this file. We'll use this address on the Rinkeby test network. We want to transfer to this, and we want to, actually Dapp token sale. We want to provision some of these tokens. So we need a deployed instance of this, ERC20 token on the Rinkeby test network, and we're going to have to do this inside the Geth Console. So how do we do that? Well, I'm going to show you. We're going to use the Web3 library to get a deployed instance of this contract. It'll be, something in JavaScript that we can use and understand to call this transfer function. And we're going to need to track this admin, which was just the first account in our list. So let's set up some of these things in the console. First, we'll keep track of our admin. So open the console. Actually, let's clear out. We'll keep track of the admin. Let's say var admin. This will equal ETH accounts 0. This is the account that we deployed with. So we'll use this as the admin. And we'll say tokens available is how much? 750,000. So we'll do that here. Tokens available. 750,000. All right. And we will, get the address for the token sale. And we will, copy that address from our configuration. All right. Now, the last thing we need is a deployed instance of this token contract, so we can call the transfer function. Now, this is going to require a couple steps. We're going to use the Web3 library to get an instance of this token. So we'll need to do two things. We'll need to tell Web3 what this token looks like, how it behaves, what functions it responds to, etc., etc. And then we will do the second step, which is tell Web3 where this token is located on the network. Basically, we need to give it an address. So I'll sketch these steps out here for us. One, we will, describe the token to Web3, and I'll show you this is going to be with an ABI file, and we will give or tell Web3 the token address. All right. So how do we do this? Well, we can look at this JSON file that we referenced here with the address, and we can copy this thing at the top called an ABI. Now, the ABI is a abstract binary interface that basically is used with the Ethereum virtual machine, allows us to be encoded and decoded, etc., etc. But it also allows you to create kind of an instance in JavaScript with Web3. So this ABI just tells us like what this token responds to, right? It's got a function name for buy tokens. It's got it tells you all kinds of stuff, right? So I'm actually in the wrong thing. I'm going to not token sale. So what we want to do is take this ABI array. We want to copy it and put it in our console and, assign it with Web3 to a contract, and so that Web3 knows like how to use this contract. So I'm going to do this. I'm going to press enter here. Actually, I'm just going to copy this array. I'm going to do this in my text editor. You all can do this in a variety of ways. I'm just going to make this cleaner. And I'm going to use a plugin called Pretty JSON. And I'm going to compress this so that it's on one line. I can copy it into my console. You can do this a variety of ways. You could minify this on the web with a web tool or something, or just paste something into your console. But I'm going to do it this way because it's easy. And I want to say ABI. So var ABI. And I'm going to paste this array that we created. All right. So we have access to that ABI in our console. Now we want to tell Web3 what the token address is. Token address. And we'll find that at the bottom of this file as well on the Rinkeby network. Copy this. All right, so we got token address. Now this is an important step. Don't confuse this with the token sale address that we created earlier. We want the token address. All right, so now we have these two pieces of information. We have the information to describe the contract. We have the ABI in our console. And we also have the address so that we can tell Web3 about the address and where it is on the network. So let's get a deployed instance of the contract in the console. I'll do that like this. We'll go, let's say var token contract equals Web3 ETH contract. We'll pass in the ABI that we saved. All right. All right, now we can see that we have a Web3 object here. The next thing we want to do is get an instance and say token instance is equal to my contract at, and we're going to pass in the address that we gave it earlier. This is token address. Now make sure you don't pass in the token sale address. We want the token address. Uh-oh. Oops, sorry guys. I just had I don't know what I was thinking. Token contract. So token instance equals token contract at token address. All right. It's actually harder to type and talk than you think. So now we have a token instance. This is actually a deployed instance of our smart contract in the console. So we can call functions on this. So let's just kind of see before we do anything crazy what we have access to. We'll go to our contracts, our token instance, and we can get the name. All right, name. Yeah, there we go. Dapp token. So we are reading data from the smart contract on the Rinkeby test network in our console. So that's huge. We know that we've deployed this correctly, and then we can actually read data from it. I mean, there's no other way that we'd be able to find this information unless we had done that. Like I say, address. All right, D1A2. That's going to be the same address that's here. D1A2. That's on the Rinkeby test network, so it's not local. All right. So the last step that we need to do before we can actually interact with this is to transfer the tokens. So go back to our test and see what we did. We took the instance, which we have here, a token instance. We want to call it transfer. All right. We want to pass in the token sale address. And we want to give it the tokens available. All right. And we want to do from admin. All right, because that's exactly what we did in our test. All right, let's see if it works. Okay, what happened? Let's check. We can check to see token instance balance of. We'll say admin. All right, sorry, I had a little hiccup there, guys. But you can see if you type, token instance balance of, the admin, you can see that it's gone down by the amount that we expect. If we do the balance of the token sale address, it's gone up by the amount we expect. So I did this the first time, and this hadn't actually finished yet. That's why I had a little hiccup in the video. But yeah, this is an asynchronous call, so we have to wait for the transaction to finish. And once it did, we saw that we actually provisioned the number of tokens that we expected to the token sale. So if if this doesn't work for you initially, remember this is potentially a long-running command that might take a second. So just wait and see if it works. All right, so that's huge, guys. We have set up our token sale contract with some tokens. All right, so the last thing we want to do is actually connect our client-side application to our smart contracts that are connected to the Rinkeby test network. In order to do that, we need to first import our account that we deployed our smart contract with, or any of the accounts that we created in Geth that have Ether on the Rinkeby test network, and we want to basically get those from our machine and import them into MetaMask. So we can find our accounts. We can find the JSON files that we'll use to import into MetaMask, the key stores, like this. If you're on a Mac, you can go to, you can just say ls-l, this would be library, Ethereum, and we can say Rinkeby and key store. And so we can see the files that are listed here. These are the JSON files that are going to correspond to each account that we created with Geth. So if you only created one account, you'll only see one JSON file here. If you created multiple, you'll see multiple. So I'm going to actually just show you this in Sublime Text so that you can get an idea of what's going on here. All right, so here's the directory open in Sublime Text. You can see that there's 5 files because I have 5 accounts. You might only have one if you just created one. So you can click on this and see a JSON file. Now we need to get this JSON file into MetaMask. We want to upload it into MetaMask. So I'm going to first just kind of copy this and put it in our project. So just copy this JSON file and put it here. Now this is not really recommended best practice, but I'm going to just add it to our project. Just make sure you do not commit this. Do not commit this to history. So I'm going to copy that JSON file and add it here. I'm going to save it as just keystore JSON in our project. All right. So I've copied this account into our project, and I'm going to upload this into MetaMask. Now this JSON file is just what we can use to, import our account to MetaMask. We'll use the password that we created whenever we created the account as well. So let's go to our client-side application by running npm run dev. And this will open Light Server, and it'll open our app. So now we can go to MetaMask and we can see that we have nothing here because this account doesn't have anything. So we want to, import that account and you just use this. So let's go to import account. We will select a JSON file instead of a private key. We will open this file here. You can see this is our project where I just saved this keystore.json. And I'll click enter. All right. We'll have to enter the password that we used when we created the account with Geth. All right. We'll let this import. Let's look. Okay. And we can see that we have imported our account from the JSON file with Geth. I have 15.78 Ether here. Again, this is just the Rinkeby test network, not the main Ethereum network. So this Ether's not worth anything. We're just going to use it to purchase some Dapp tokens. So I'm actually going to edit this account and rename it. Say Rinkeby 1. And also we can just verify that this is the same account if you wanted to. We could copy the address to clipboard and go check it in Geth, but I'll leave that up to you. All right, so we'll refresh this page. And we can see that we currently have 250,000 Dapp tokens, right? Because that was the first account that initially had all the tokens. And we, provisioned some to the token sale because we're the admin. And yeah, we can see that our front-end client, our token sale website, is talking to the Rinkeby test network. So we have made a successful deployment. We have added the account to MetaMask. The next thing we want to do is see if we can actually purchase some tokens. So let's just say we want to buy 100 tokens, and let's try to purchase it. We'll see our MetaMask confirmation pop up. It's going to cost us something, and we will submit. And we'll wait. And I'll open up the console just to make sure that we don't have any errors. So on the Rinkeby test network, I'll give you a heads up. This can be kind of slow if you're trying to just create, send transactions directly. So you might have to wait a second. I'll just cut the video so that you don't have to watch all this. So actually, we can see a token was bought or callback was successful. And boom, we found our event. And we can see that we purchased some more Dapp tokens back into our admin account. And we can see that we have 100 of 750,000 tokens were sold. Awesome. So yeah, guys, we have successfully taken our contracts and deployed them to a test network, gotten them off of our machine. We've added these accounts with Geth. We've provisioned all the tokens to the token sale. And we're actually talking to a live token sale ICO on the Rinkeby test network. And we can purchase tokens. And now we have Dapp tokens that we can, hold on to and save and send to other people and use as a currency. And a quick addendum before we wrap up. Make sure you go back to your project and delete this file. We can go ahead and commit some of our changes. You can see that it's mostly just these JSON files changed. Let's call this deploy contracts. All right. All right, so that's it, guys. That's the end of this video where I show you how to deploy your smart contracts to the Rinkeby test network. That was pretty involved. There's a lot of steps, a lot of things that can go wrong. So if you have trouble, just try to break it down step by step and see what you're having an issue with. So be sure to subscribe to the channel so that you can see the next video in the series where we're going to actually deploy our client-side website to the web, and then we'll have a fully functioning ICO that's out there for the World Wide Web to see, and they can actually purchase the tokens on the Rinkeby test network. So subscribe to the channel and turn on notifications below so that you can see that video when it comes out. And until then, Thanks for watching Dapp University.